Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We are from group 2 and from class of CDCS 3F. Today we're going to talk about technique of differentiation. And our group member is first Muhammad Najwan, second Muhammad Rafiq, third is Muhammad Syafi'i, and fourth is Tengku Anik. And for question 1, what is meaning of differentiation? Differentiation is the process of finding the derivative of function. The derivative represents the instantaneous rate of change of one variable with respect to another. In real life application, differentiation is used to describe how quantities change as a velocity as the rate of change of displacement. And there are a lot of technique of differentiation. And first is derivative of constant function. Second, derivative of power function. Third is derivative of sum and differences. Fourth is product rule. Five is continuant rule. And six is chain rule.
We are given the function y equals contingent of e to the power 2x multiplied by x to the power 4. So this function is a composite function. The outer function is contingent e to the power 2x multiplied by x to the power 4, and the inner function is e to the power 2x multiplied by x to the power 4. Since the inner function is a product of two functions, we need to apply both the chain rule and the product rule. First, we differentiate the outer function. The derivative of contingent is negative cosecant square of e to the power 2x multiplied by x to the power 4 multiple d by dx of e to the power 2x multiplied by x to the power 4. Second, in inner function, we must apply product rule. So we can call it this equation to u v prime plus vu prime. By letting u equals e to the power 2x, u prime equals to 2e power 2x. For v equal to x power of 4 and v prime equals to 4x power of 3. Then we substitute into equation and it become like this. So after that, we must factorize the common term. So the common term is become like this. So we must factorize e power of 2x multiplied by x power of 3. So this is the answer. And factorize, don't forget to factorize 2. And we must substitute back into derivative. So the final answer is this.
To proceed with question 2b. Given question 2b, fx 2 equal to 2x minus 1 divided with ln 4x. First, we need to identify the method. The function is continuant, meaning one function is divided with other. And we use the continuant rule, which is state f prime x equal to u prime v minus v prime u divided with v power of 2. And step 2, we need to define of u and v. First, let u equal to 2x minus 1 and we got u prime equals to 2. And we let v equal to ln 4x. And to differentiate ln 4x, we use the chain rule. Derivative of ln 4x is d equal to d divided with dx ln 4x equal to 1 over x. And step 3, we substitute into the continuant rule. We substitute u, v, u prime and v prime into the formula. And we got f prime x equal to 2 ln 4x minus 2x minus 1 and 1 divided with x. Divide with ln 4x power of 2. And the last step is simplify. We got 4x equal to 2 ln 4x minus 2x minus 1 divided with x and divide with ln 4x power of 2.
Okay, hi, my name is Tengku Anik Hakimi Salamuddin. I will be presenting the question 3. The question 3 is given y square sine of x minus exponent of 2 minus 3x equals to ln y per x minus 3x. Find dy dx by using implicit differentiation. So this is the question that's been transferred to my slide. So the step 1, we must differentiate both sides with respect to x. So by letting a equals to y square sine of x, I'll be using product rule because y square is multiplied by sine of x. So by finding u v prime plus v u prime, we will get this answer, and we will further simplify this answer to y square cos of x plus 2y sine of x dy dx. So next, by letting b equals to exponent of 2 minus 3x, I will be using chain rule. So by using chain rule, we will get the b prime is negative 3 exponent of 2 minus 3x. So next, by letting c equals to ln y per x, we can simplify this term. It will become ln y minus ln x. So c prime is 1 per y dy dx minus 1 per x. Next, by letting d equals to negative 3x, so d prime is 3x. Step 2, I will be setting back the differentiated term into the original position. So A prime will be this term that we did for A prime, minus B prime equals to C prime minus 2D prime. Next, step 3, I will be isolated the dy dx to the left side. So if you want to isolate the dy dx, we must transfer the term that has dy dx from the right to the left. So by transferring the term that has dy dx to the left and that don't have dy dx to the right, we will get this equation. After we get this, we can factor out the dy dx. So it will be dy dx multiplied by 2y sine of x minus 1 per y equals negative 1 per x minus 3 minus y square cos of x minus 3 exponent 2 minus 2 exponent of 2 minus 3x. Next, step 4, I will solve for dy dx. So by transferring um, the term that I've factored out the dy dx to the right, so we will get this new term that is has a numerator and denominator. So to simplify this equation, we will multiply by xy because there is a smaller fraction which is 1 per x and 1 per y. So we will multiply xy to the numerator and denominator. So we will multiply xy to the denominator and denominator. It will be this new answer. Negative y minus 3xy minus x square cubed cos of x minus 3xy exponent of 2 minus 3x per 2xy square sine of x minus x. So next, we can this is not a complete answer, so you can factor out negative 1 to get a cleaner final answer by eliminating the negative sign. So we will factor out, so we multiply negative 1 for each for numerator and denominator. We will get the final answer. Dy dx equals to y plus x 3xy plus xy cubed cos of x plus 3xy exponent of 2 minus 3x per x minus 2xy square sine of x.
Question 4. We are asked to use linear approximation to estimate the value of ln of 80.97 minus 1 over the fourth root of 80.97. For step 1, we first choose a reference value x naught that is close and easy to work with. So we take x naught as 81. Then we look at the actual value given in the question, which is x equals 80.97. This makes delta x equal to x minus x naught, which is negative 0.03. The function we use is fx equals ln x minus 1 over the fourth root of x. Next, we find f at x naught, so we calculate f of 81, which is ln 81 minus 1 over the fourth root of 81. The fourth root of 81 is 3, so expression becomes ln 81 minus 1 over 3. After calculating, the result is 4.061115821, and we round it to 4 decimal places to get 4.0611. For step 2, we need to find f prime of x and f prime at x naught. We start with the original function fx equals ln x minus 1 over the fourth root of x, which we rewrite as ln x minus x to the power of negative 1 over 4. The derivative of ln x is 1 over x, and the derivative of x to the power of negative 1 over 4 is negative 1 over 4 times x to the power of negative 5 over 4. Because the original expression has a minus sign, the derivative becomes positive. So f prime of x is 1 over x plus 1 over 4 times x to the power of negative 5 over 4. Then we substitute x naught, which is 81. So f prime of 81 is 1 over 81 plus 1 over 4 times 81 to the power of negative 5 over 4. After simplify, the value becomes 13 over 972. For step 3, we apply the linear approximation formula, where fx is approximately equal to fx naught plus f prime of x naught multiplied by x minus x naught. So for f of 80.97, we substitute fx naught with 4.0611 and f prime of x naught with 13/972, while x minus x naught is negative 0.03. This gives f of 80.97 approximately equal to 4.0611 plus 13/972 times negative 0.03. After calculating the expression, the estimate value is 4.0607.